LeetCode 141, Linked List Cycle. Given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. And here's an example where we're given nodes 3, that goes to 2, that goes to 0, that goes to 4, that then goes back to 2. We can clearly see there's a cycle. The approach that we're going to be taking is called Floyd's cycle detection algorithm, or Tortoise and Hare algorithm. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal solution to this problem. Now let's walk through an example. 3, 2, 0 and 4. Step 1. Declare two pointers, fast and slow, both starting at the head. We can see F for fast and S for slow here, pointing at 3. Step 2. Loop over each node while fast and fast.next is not null, applying the following logic. Fast is equal to fast.next.next, so let's update the fast pointer. Check if fast is equal to slow, which we can clearly see it is not. So then update slow to slow.next. Then back to the top and set fast equal to fast.next.next, which we can see is 2. Check if fast is equal to slow. It is equal to slow, so let's return true. And note step 3, if we break out of the loop, there is no cycle and we need to return false, so return false. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode Problem 141, Linked List Cycle in Java. So given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. And we're given 3 examples. Example 1, we've got nodes 3 that goes to 2, that goes to 0, that goes to -4, that then loops back round and goes back to 2. So we can clearly see that there is a cycle in this linked list, so the output is going to be true. The second example, we're given 2 nodes, node 1 and node 2. And node 2 we can clearly see comes back and links to node 1, so we do have a cycle. So again, example 2 is going to have an output of true. Finally, we're given a single node in example 3, and the result of this is going to be false, because obviously you can't have a cycle in a linked list if there are no links and there is a single node. So in terms of edge cases that I can think of, we've seen a couple of them in the examples there. So one edge case that we didn't see was where we're given an empty linked list. So if you're given an empty linked list, then obviously there can't be a cycle if there's no nodes and no links. So in that scenario, your solution you'd want it to return false, because obviously there's no cycle. A second scenario would be where you are given a single node, which is what we've seen in example 3. In that scenario, you can never have a cycle because there's no links, which means you're always going to return false. If we look at example 1, but imagine that -4 did not link back to 2, that would be another edge case where there are no cycles in the linked list, and that would be another edge case that you would want to cover when creating a test or doing an interview sort of situation. You'd want to bring that up. Cool. Now let's get into the actual solution. So we want to declare 2 pointers, which are going to be list nodes. List node, I think, is it a list node? Yep, it's a list node. we'll call it fast. I'll call this one slow actually. Slow, we'll set it equal to head. Then another list node, and we'll call this one fast. List node equals, list node fast equals head. And then we want to loop over the linked list using fast. So while fast doesn't equal null and fast.next doesn't equal null, then we want to say that fast is equal to fast.next.next. We want to check if fast equals slow. If fast does equal slow, then it means that the nodes are the same and we have got a cycle in the linked list, so we want to return true. And then if that case is not true, then we want to go to the next node that the slow is pointing at. So we update slow. So slow equals slow.next. Now, if we get to a scenario where fast and fast.next if one of these equals null, it means basically that we've got to the end of the linked list without detecting fast equaling slow, which means that there is no cycle in the linked list. So basically, if we break out of the while loop, we want to return false because there is no cycle. And the reason that this works is because if you imagine, if we start with fast and slow, both pointing at 3, so we go to the first iteration where fast goes to next, and slow just goes to the 2. Then we do it again, then fast goes next. Then we can clearly see in 2 cycles of the while loop, both fast and slow will be pointing at the 2. And that is the correct result of what we would want. We would want to say, yes, there is a cycle. So let's run that, see if it works. It does, great. Now let's submit it and see if it passes their test cases, which it does. And according to this, it beats 100% in terms of runtime complexity and 39.81% in terms of memory. So I can tell you that the runtime complexity of this solution is O of n, and the space complexity is O of 1 constant, and this is the optimal solution to this problem. Thank you very much for watching. I hope that you like the content and this has clarified this problem for you. If you could please click like and click subscribe, that would massively help out me and my channel. If you've got any feedback that you've got for me, or anything that I can improve on, or if there's any videos that you'd like me to produce in the future, please leave them in the comments below and I will get back to you. Thank you very much for watching and good luck with your coding.